right, so the graphs of polynomials. If we look back to where we named them, these are the graphs that we're going to look at. So not specifically if it's a monomial, binomial. That really doesn't matter with the shape of the graph. We're looking at these. So the first one is the constant. And that's if we have like y equals some number. I'm just going to put a number sign there. So like y equals 3. That's a constant. Y equals 7. That's a constant. And so the graph of that, if I'm just going to type those into my calculator. So like y equals 2. If I look at the graph of that, notice it is a horizontal line that crosses the y-axis at 2. So a constant graph looks something like that potentially. It could be anywhere on going across that y-axis, but it's a horizontal line. A linear, this is like y equals, I'm just going to put y equals x because that's, when we say the word parent function, we're talking about just the very basic original function. So y equals x is just the original. So think back to Algebra 1. You had like y equals 2x plus 5. You did rise over slope and y-intercept. That is a linear function. And so most of your graphs look something like this. On linear functions. You did those in Algebra 1. Y equals mx plus b. Okay. Quadratics, we did those in Unit 5. Y equals x squared. Those look something like this. There's a lot of factors that could change the way this looks. Sometimes they're upside down. Sometimes they're skinnier. Sometimes they're wider. But this is just kind of the basic one. This is what a basic quadratic looks like. Cubic, this is y equals x cubed. And it looks something like this. Quintic is y equals x to the 4th. If you were to type this into your y equals, it's going to look a lot like the quadratic one. So I'm going to show you what a quartic could also look like if it's got like other things added onto it. So it could look like this. Okay. A quintic, y equals x to the 5th. If you only type in x to the 5th in your y equals, it's going to look a lot like the cubic. But again, if I had like 2x to the 4th minus 3x cubed, things added onto it, it can really change it. So this is potentially what it could look like. It could cross the x-axis like 5 times. That's kind of how I determined. I counted as I went. But the arrows point in opposite directions. So if you see a graph and it looks a lot like this, it's probably a quartic graph. So the way that the arrows point, that's what we call the end behavior. So notice here, like on the quartic one, the left side, the arrows point up, and the right side, the arrows point up. Over here, the quintic, we have one that points down and one that points up. Same with the cubic. That is called our end behavior. And the end behavior is determined by 2 things. One, the leading coefficient. Do you all remember what the leading coefficient is? The number in front. And all we care about is if it's positive or a negative number. That tells us one thing. The other thing we look at is the degree. What is the degree? The largest exponent. And with that, we want to know, is it even or is it odd? And if we know those things, I can tell you what the end behavior is going to look like. I can tell you if the arrows are pointing down or if the arrows are pointing up without looking at the graph. So I'm going to fill in this chart for you. So if your polynomial has a positive number in the front and the degree and the largest exponent is an even number, then both of your arrows point up. So the left side points up, the right side points up. And so we would say it rises left, it rises right. So on the left side, it's pointing up, which we call rises. And on the right side, it's pointing up, so it rises on the right. Now, if we have a positive number in the front and an odd degree, then your arrows are like this, much like the x to the third and the x to the fifth. So on the left side, it's pointing down, which we use the word falls. So it falls left, rises right. So it falls on the left, rises on the right. If we have a negative leading coefficient, so a negative number in the front and an even degree, both arrows point down. So it falls left, falls right. And this last one, we would have up and then down. So it rises left, rises right. Yes. Thank you. So we're going to do some examples. Now on the back side, so you don't have to keep flipping back and forth, I put a little place for you to recopy this chart down, and we could just put the arrows. So we have up, up, down, down, down. That way you don't have to flip back and forth. So looking at number 1, let's first look at the leading coefficient. That's the number in the very front. And we want to know, is it positive or negative? So is that number in the very front that I highlighted, is that positive or negative? Positive. So it's going to be one of these two. Okay. And then, hold on, my degree is the largest exponent, which is also 4. So is that even or odd? Even. So I've got a positive, even. We're going to have 2 up arrows. So rises to the left, rises to the right. And you could look at the graph of this. 4x to the 4th plus 6x cubed minus x. And you could just look at it to see. Now keep in mind that your calculator doesn't actually put arrows. So you have to recognize that I'm going to have an up arrow on both of those sides. But if you've got the chart here, it can probably save you some time and you don't have to type it in. All right, number 2, my number in front is what? What's my leading coefficient? -1. So it's going to be one of these two down here. And my degree is the highest exponent, which is what? 2. And is 2 an even or odd number? Even. So negative, even, they both point down. So it falls to the left, falls to the right. Number 3. Let's look at my leading coefficient. Is it positive or negative? Positive. So it's going to be one of these two. Is my degree even or odd? Odd. 3 is an odd number. So positive, odd. The left arrow points down, so it falls to the left. The right arrow points up, so it rises to the right. Are there any questions so far? Number 4, my leading coefficient is what? -1. So negative. It's going to be one of those two. And then my degree. Is my degree even or odd? Odd. It's 3, which is an odd number. So negative, odd. I'm going to rise. Rises to the left. Falls to the right. And again, I could type this in, -x cubed, and look at the graph. But then you got to wait on it. So notice on the left side of the graph, the arrow would be pointing up if I drew in an arrow. And on the right side, we would have an arrow pointing down. Try numbers 5 and 6 on your own. All right. Number 5 should have falls. Because the number in the front is negative, and then with the degree, it's even. So negative, even, that's this box right here. And then over here, the number in the front, don't let the fraction throw you off. We only care if it's positive or negative. I don't see a negative sign, so it's positive. And then the degree is 3, which is an odd number. So falls, rises. Number 7 and 8, I'm showing you a picture of the graph. You have to tell me if the leading coefficient is positive or negative, and if the degree is even or odd. So look at the arrows. How are the arrows pointing? They're both pointing down. So if you look at your chart up there where they're both pointing down, is the leading coefficient negative or positive? Negative. Is the degree even or odd? Even. Good. Number 8, the left arrow is pointing down, but the right arrow is pointing up. So look at your chart to see where we have left is down, right is up. Is the leading coefficient positive or negative? Positive. Is the degree even or odd? Odd. Are there any questions? Now we're going to get into something called turning points. A turning point is where the polynomial changes direction. So it goes from going uphill to downhill. So the very top, tip top, or downhill to uphill would be the very, very bottom. So we're looking at like this point and this point. Those are turning points. If the point is higher, if it's at the top of a hill, we kind of looked at this in quadratics. Do you remember what we would call the point if it's at the top of a hill? A maximum, specifically a relative maximum. And we call it the relative max because really, since this goes up forever, there really is a point that's higher than that. Every point up here is higher. So a relative max means just out of all the humps. It's the highest point out of the humps. So it's the highest one that you can just pinpoint right there. That's all that you have to worry about. If it's lower, so if it's in the valley, we call it a relative minimum. And we'll use these turning points for a lot in the next few lessons. So you've got to get really good at picking these out. All right. So let's turn the page, and I'm going to tell you how to find them in the calculator, and it's super easy. All right. So get your calculator. Turn it on. Gotta be following along with me. Don't just watch. Because you're going to have to know how to do this. Because you got to do this to be able to do several things. All right. So go to y equals and type in the function. So what's the function up here? X cubed minus 6x squared plus 7x plus 2. And if we hit the graph button, we will see that.
One straight line.
Your calculator was zoomed way out. All right, so I'm going to just sketch the shape of this, just like this. And go back to your y equals and see if there are other things typed into your y equals. Go to y equals. Hit y equals, and if there's other things, there probably are because of what my advanced algebra 2 is doing. If you get one, just hit clear, go down and hit clear. If you've got more things going on there. Okay. And so we've got 2 points. This one right here, is this a max or a min? It's a max. This one down here is a minimum. But we are going to write out the actual coordinates. So I'm going to write max. I'm going to write min there. So we're going to actually put the coordinates. So we only have one maximum, one minimum. Sometimes you might have two max and a min. The way that you find these is using the trace button. So where it says trace, hit that. And you should probably see a blinking cursor on your graph. Does anybody not see that? And you can use your left and right arrows to get this spot. Oops, I don't know what I just did. Hold on. Okay, not sure what button I hit, but okay. So right here, it looks like the maximum. Now, because we're using the trace button, your numbers could be slightly off from mine, because if you're not in the exact spot that I am, it could be off a little bit. So just keep that in mind. But now if it's way off, then I know something's wrong. But if it's like 1 decimal place off or something, that's okay. So this one that my cursor on is the maximum because it's at the top of the hill. And I want you to round to like 2 decimal places. So 0.76, 4.29. So it tells the x and the y. That's your point. That's the x value and the y value there. And then I'm just going to use my right arrow to go on over and get the minimum till I'm down in the valley. And this is the point 3.33, comma, negative 4. Now if I'm rounding 296, that would make the 9 go up. So I'm just going to put negative 4.30 because basically that 29 goes up to 30. I'm not going to be super picky on these because it's easy to be off just a hair, but now you got to make sure you don't want your cursor to be way over here. Okay, you want it to be at the top, the best that you can get it. Like the test will be multiple choice. So you'll have to recognize, you'll just basically look for the one that's really close to what you've got. So any question? So we've got 4 questions here. We're going to list out the max and the min for each of these. So let's go to number 9. Negative x to the 4th plus 4x squared minus 2x minus 1. Hit your graph so it'll draw it in. And I do want you to sketch out the shape of it. Okay, it doesn't have to be perfect. And write if it's a max or a min. Because I want you to get really good at recognizing what's what. So in this one, we have 2 maximum points and 1 minimum. So we have 2 hills, 1 valley. If I hit trace, now I like to work left to right. That's how I do it. That's how I would prefer that you do it. So the far left, I get my first max, which is right here. So this is the point negative 1.52, comma 5.94. And I'm going to use my arrow and go down to get this minimum. Now, you might be like, oh, 0, -1. That's actually not the minimum, because if I go over just a little bit more, this -1.24 on the y, because that's a smaller number, that means it's farther down. So really your minimum is 0.3 -1.25. So on a minimum, we're looking at the y value. We want the lowest y value. And the maximum, we want the highest y value. And then I use my right arrow to go look for the max. So that one looks to be the highest y value in that area.
I went down one more with that cursor on the min, and I got 0.15 and -1.21.
That's fine. .21, 0.29. As long as you're really close. I mean, if you have like 1, -2, that's not close. When I'm saying close, I'm talking about like a few decimal points away. Close. Any questions on finding these? Let's do number 10 together, and then I'm going to let you do 11 and 12 on your own. So x cubed plus 2x squared minus 4x minus 1. This one has 1 max and 1 min. Now this first max is -1.97. The y value is 6.996. So when I try to round that, it's just going to round up to 7. And then the minimum, go down, 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 down. So the lowest, if I'm not really looking at the graph, because sometimes the cursor can be misleading. I'm looking at where it actually has the y value, and I'm looking for the lowest number. So -2.46 is actually lower than -2.44. But those are really close together. So if you get one click off, that's fine. So this minimum is 0.61, comma, -2.47. I want you to work on numbers 11 and 12. If you see a number on your calculator that looks, I'm going to make something up, 4.2593075, and then it'll say E -10. This is scientific notation. What that means is, I don't know what the E stands for, to be honest, but what it means is that I'm going to move the decimal point left 10 spots. So if I move it left, I'm moving it over, over, and you'd fill in all of those with zeros. So this would be like 0.00000000425 and so on, which is essentially what? What is this? 0. 0.00000 is basically 0. If you get an E, you got to be watching out for that. If you see an E, just put 0 down. Don't put 4.26. Put 0. I don't know why the calculator doesn't just put 0, but it doesn't. So number 11, you should get roughly 1.974 and minimum 0, 0. Did y'all get that? Close to it. Go back and you might have, if you didn't get that, you might have missed something on the graph. Maybe you didn't put the negative. Yeah, that's fine.
I got for the max 0.98 and 1.71.
You probably just typed something in the graph wrong. And then number 12, your max should be 0.4. And then minimum negative 1.67, negative 1.25, 0.91, 2.95. Roughly. Very close to that. If you got way off, then you messed up somewhere. It's really easy to miss a negative or just type in a number wrong. So be cautious with that. Any questions?
So that you just want like 1, 2 far on each